Oh, everybody hear me out there in Zoom land? One, two, three, four, five, six, seven, eight, 9, 10 people. Got a yes. All right, good. All right. Let's go ahead and get started. All right, it's a minute early, but that's okay. So graphing, right? Inequalities. First thing we're going to do is put it into y equals mx plus b form. So we got a 3y less than or equal to. We subtract the 2x and subtract the 2. Divide everything by 3. So negative 2/3 x minus 2/3. This one's going to be ugly to graph because it's thirds. So instead of making each tick mark worth 1, we'll make it worth 3. I mean, worth the third. So 1/3, 2/3. So that point right there will be 0, negative 2/3. So each tick mark will be worth a third. All right. Our slope is negative 2/3. So for every 2 I go down, I have to go to the right 3. Or for every 2 I go up, I have to go to the left 3. So we could pick any one of these we want. Let's see, what would this would be? If this is negative 2/3, 3/3, 4/3, and then 1/3, 2/3, positive 1. And we could draw our line. So that's where y equals this stuff, and we want everything less than that, so it'd be everything down here. All right. So the next one, same thing. We put it into slope intercept form. Y less than or equal to. If I add 4 to both sides, I get what, a 6. And I'll add x to both sides. So if I graph this, easy to screw these up. I screwed this one up yesterday after class. Or intercept here is at 6, so I'll make each one of these worth 2. So I'll make that point there 0, 6. So each tick mark vertically is going to be worth 2. The slope here is a positive 1, so this thing is going uphill. So for every 1 I go to the right, I have to go up 1. Or every 2 I go to the right, I have to go up 2. There's our line. Let's label another point. We could pick any point we want. Pick this one. So that's 6. I would have a y value of 8 and an x value of 2. And we want everything less than y, so it's everything down here. That makes sense? For x-intercept, our slope here is a positive 1. First time I did this, I used the slope of negative 1 on accident. It's going downhill instead of uphill. That would correct my solution. So that's the last exam. Today we're going to be doing functions, and so for our quiz, I'll give you an easy quiz. This is number 7. We evaluate the function. So number 1, find f of 3 if f of x equals 2x squared minus 3x plus 1. And number 2, I'll write it in a different way. Find f of x evaluated at a squared plus 1, or f of x equal to x squared plus 1. So this should be pretty easy, okay? If y'all remember anything about functions, this means replace the x with a 3. Evaluated at this, that means replace the x with a squared plus 1. All it is. So let's take like 5 minutes to do this one. So, or 6 minutes. So 5:40, we'll move on. There we go. All right. So all we're saying is replace x with the number 3. So f of 3, replace x with the number 3. Okay. So 3 squared is 9. 3 times 3 is 9. 3 times 9 is 18. So 18 minus 9 is 9, plus 1 is 10. That is our f of 3. All right, so here we're saying we're going to evaluate f at this. That means replace x with this thing. Just like up here, I said evaluate the function. This is f evaluated at 3. We need to evaluate f at a squared plus 1. Well, f of x says take your input, here's our input, and square it and add 1. So we square the input and add 1. Okay? Input, square it, add 1. Input, squared it, add 1. We can multiply it out if we want, but that's the answer. Okay? If we want to, you could say, okay, a squared squared would be a to the 4th. Then we'd have a squared times 1 plus 1 times a squared, which would be 2a squared. And then 1 squared is 1 plus 1, be a to the 4th plus 2a squared. 1 plus 1 is 2. So either one of these is fine. Okay, they're equal. Any questions? This? Okay. Here's a note. If we have x plus y squared, right? Right, this is going to be x plus y times x plus y, right? We got an x times an x times a y times an x, and a y times a y. Follow that? Well, these are the same, x times y and y times x, so it's 2xy. Right? If you remember squaring things, so we have something squared, so it's this thing squared, and then twice 1 times the other. So that's where the 2a squared comes from. Remember, x plus y squared is definitely not x squared plus y squared. There's the interference terms, what we would call them. All right, y'all need a recap on that kind of stuff, the distributive property. Let's do a, if I have x plus y plus z times an a plus b plus c, how do I multiply this out? Well, y'all might think FOIL, but FOIL is bullshit. FOIL only works if you have 2 things times 2 things. It's a mnemonic that'll give you an answer so you don't have to understand anything, right? All of this is just a distributive property. What do we have here? We have an x times all this stuff, and then we have a y times all this stuff, and then we have a z times all this stuff. The distributive property, x times that, y times that, z times that. So we have an ax, a bx, a cx, an ay, an ab, and I'm sorry, not a b, by, and a cy. And we have an az, a bz, and a cz. Just a distributive property. All right, now you can multiply any number of things times any number of things. All right. Distributive property. Okay. All right, so apparently we're bouncing back to chapter 2. We need to cover 2.1 and 2.2 today. Okay. There it is. Remember, it's always posted in the notes right after class. All right. Oh yeah, the attendance. As long as you get it in by midnight, you're good. Yeah. All right. So. All right. Equations of two variables. Y'all know what functions are. We already know how to graph. I'm not sure why we're going back to chapter 2 now, but let's see. That's what it says to do. Plotting point by point. Okay. That's one way to graph, right? Remember, your input is left and right, your output is up and down, right? So X is left and right, Y is up and down. So if you can't look at that and just know what the graph looks like, you could plot points. If I let X be 0, then Y has to be 9. So down here I go 0, up 9. There's a point on my graph, 0, 9. If I let X be 1, 9 minus 1 is 8. So when X is 1, the Y value is 8. So 1, 8 is a point on the graph. And you could do that as many points as you want and then connect the dots. Okay. You could do the same thing for this one. All right. So that's one way to graph. Kind of the lazy way, really. Actually, it's the hardest way to do it. Right? The best way is to know lots of reference graphs and be able to visualize it via transformation. So here is x squared equals y to the 4th. Okay. And pick any point you want. Like, what's this point here? This would be 9 minus 3. Okay, well, 9 squared is 81. 1, 2, 3. Now we're going down 3. And minus 3 to the 4th is also 81. Okay. So any point on here, the x and the y are going to satisfy this relationship. That's what it means to graph something, right? Some people like this visual more than they do this equation, right? It just depends on how your brain works. You know, you want to be able to bounce back and forth between the two, you know? You work with the equations and the graphs enough, you get to where you can look at graphs and just write down their equation fairly easily. Right? I wouldn't have guessed that the graph of this looked like this. Right? I should. I'm a mathematician, but I've been out of practice for 10 years, so. The definition of a function. All right. See if they have it in. Thing you need to know about a function, like there's lots of relationships. You can write down any equation you want with an x and a y in it, right? Like that x to the 4th, no, it was x squared equals y to the 4th, right? That's an equation with two variables. It's not a function, all right? Yes, you can graph functions and you can graph any equation like this, but not all graphs are functions. A function is a specific type of relationship between two variables where for any one number in, you get one number out. All right, so a function f, we'll name it f, it maps one number to one number. Okay, so if I plug in one number, I should only get one number out, right? So this table here, the domain is the numbers you plug in, and the range is the numbers that come out. So on a graph, the domain would be how far your graph goes left and right, and the range is how far it goes up and down, okay? But this would be a function because for each one number in, I'm only getting one number out. One number in, I get one number out. So this would be a function, okay? This guy over here, one number in, one number out, 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 one number in, one number out. So it's a function. Yes, it has this property where both -2 and 2 both give me a 4, right? That's okay. The point is I'm plugging in one number and I'm getting back one number. So what? Two different numbers give me the same number. That's okay. It's still a function. It's not our favorite kind of function. Our favorite kind is a one-to-one function. This is a one-to-one function. So for not only one number in and one number out, if I inverted this, if I turn this function around, turned it inside out to make it do the opposite of this function is also a function, because for one number out, it came from one number in, one number out, it came from one number in. This one, although it's a function, it's not one-to-one, meaning it's not invertible. Because if I plugged in a 4, the 4 could have came from either one of these two. So it's a function, but it's not a one-to-one function, okay? This one here, not a function. I plug in a 1 and I'm getting two numbers out, all right? So this one over here is kind of like y equals, let's see, if y is my function, and what are they doing? I'm multiplying all my inputs by 4, right? For any number in, I get one number out, 4 times it, okay? If I graphed that, it would look like this. And the thing about a function, this one number in, one number out, what that means is it has to pass the vertical line test. No matter where I draw a vertical line, it should only cross the graph once. Like this one here, let's see what's going on. They're taking all my input here and they're squaring it, right? 2 squared is 4 minus, so this is really x squared. A graph that it looks like this, all right? I can take one number. If I square it, I get one number, right? No problem. So it's a function. Everywhere I could draw a vertical line, it only crosses the graph once. So it's a function. It does not pass the horizontal line test. That means it's not a one-to-one function. That means it's not invertible, okay? This dude over here, I said it's not even a function. What did this guy do? This is like y equals, I'm square rooting. I'm taking 9. I'm getting both the positive and the negative square root of whatever I plug my input in as, right? Square root of 9 is 3. I'm saying take the positive and the negative one. So this is not a function. I wouldn't call this f of x. It's not a function. Because I plugged one number in, x, and I'm getting back two numbers, the positive and the negative of the square root. So if I plug in a 9, I'm getting both positive and negative 3. If I graphed this relationship, it would look like this. And see, it does not pass the vertical line test. It crosses it twice. So that's what makes it not a function, okay? It's actually, this is the opposite of this. They're inverses, right? So if I restricted myself to only half, if I restricted myself to x squared, but I said x is only positive, then I would only get that piece. And yeah, that's a graph, and that thing right there would be passing the horizontal line test. So it's invertible. So we'll talk about inverting functions on restricted domains, right? This guy's a function, but he's not invertible unless we restrict ourselves to only the right half. Because if I graph the inverse of that red thing, it would be this right here. And just that red part is a function. So it'd pass the vertical line test. So that's the next two sections in a nutshell. This should be review, right? The function corresponds between two sets of elements such that each element in the first set that corresponds to one and only one element in the second set. The first set is called the domain, the set of corresponding elements, and the second set is called the range. So a function takes the domain and maps it to the range. We would actually write it like this. All right, so the D is all the set of X's and the Y is all the R's, right? So we could say F maps X to Y, or F of X equals Y. Okay? So that's all it is. The function is like a machine. You put a number in and it gives you a number back. Functions don't have to have just numbers. You could plug in like days of the, or the name of a month, and the output could be the number of days that month, right? So functions aren't just about numbers to numbers. Of course, we convert everything to numbers, right? We don't use January. We use the number 1 to represent January, right? We use the number 2 to represent February, right? But functions are all about the relationships between these concepts. Come on, internet. Independent variable and dependent variable. Okay, so there's just more vocabulary. All right, let's say I say y is f of x is x plus 1. All right, this is the independent variable, and then y is the dependent variable. Y depends on x, right? I could pick any x I want, plug it in, and that tells me what y is. So that's the vocabulary. We break this down like this. Sometimes you'll just see like this, y is a function of x. When you're applying mathematics, you usually do that. But in formal math, we want to give things names. So we want to name the function as well as its output, okay? But if you're just applying math and doing things sloppily, we'll just write y is a function of x. That's how you do things in engineering and physics and everything else, okay? But for pure mathematical purposes, sometimes we want to change, have a name, the input, the operator, and the output, okay? I like to give everything a name. Sometimes it's really helpful. All right, functions specified by equations. All right, so here's the deal. They're going to give you like an equation and ask you, can that be, is that a function? Can that be represented as a function? Basically, if you can solve for y, right, and you only got one y for each x, then it'll be a function. So like this one, I could rearrange it. I could be like, I'm going to move the 3x over here, and then I'm going to divide everything by 4. And I will call my y f of x. So this one is a function because for any one x, I'm only getting one y. So I could say, yeah, that's a function. How about this one here? If I tried to deal with this one, I would be like, add x squared. And now if I square rooted here, if I square rooted both sides, I would get the plus minus square root of x squared plus 9. So this is not a function, okay? For any one number x, I could square it, I can add 9 to it, and I could square root it, but I'm getting the positive and the negative version. So for one value of x, I'm getting 2 different y's, so this would not be a function, okay? And you don't have to do all this work. If you look at something and you're suspicious that it's not a function, all you need to do is pick one number where you plug it in for x and you're getting 2 different y values, okay? On this one here, that plus and minus. So if I plugged in 0 for x, right? The square root of 9 is 3. Y is both the positive 3 and the negative 3. So I'm getting 2 values, right? If I plugged in a 0, then y is giving me, I'm getting both a negative 3 and a positive 3 right there. That tells me there's more than one value for y for each one x. Does that make sense? Okay. I guess these are the graphs down here. See, that's the graph of that one, and that's the graph of that one, right? When I rewrote this, it was just linear, right? It was this. That's just the graph of a line, right? Mx plus b. If it's just a line, sure, it passes the vertical line test. It's a function. This guy was weird, has all these squares and cubes and stuff. Anytime you see something with an even power, right, you got to be suspicious, because an even power, something negative to an even power is always going to be positive, right? So your x squared looks like this, right? It's a function, but the problem is if you turn it sideways, it's not, okay? So be careful with any of those. Like if you have an x cubed, it's an odd power. It's okay. X cubed looks like this. It's fine. All right. In fact, it's an invertible function. It's 1 to 1. And the thing is the odd powers are the ones that are really gonna an even powers. You see, like x cubed, trying to go backwards. If I got a -2 cubed, I got a -8. 2 cubed is +8. So the minuses when it comes to odd powers or cube roots, all right, they're okay because those are invertible. If you get a minus, you can get a minus out of a cube root, okay? Right, the cube root of -8 would be -2. The cube root of 8 would be 2, okay? When it comes to the x squareds, like 2 squared is 4, but -2 squared is also 4. So if I'm thinking about this going in the opposite direction, like if I rename my y and my x, right, then where did this 4 come from? Did it come from -2 or 2? I don't know. See what I mean? So the odd powers, the odd roots are nice to you. It's the even roots that are nasty, you see, because if I have y squared equals x, right, then that's the same thing as y equals positive negative x, right? And names are names. This is the same thing as x squared equals y. I could have named the y x and the x y. I could have thought it was, these are just names, right? And all this, if you change your variables, all that does is rotate your graph, okay? You switch out your x for your y, you're flipping it like that. We'll see more examples here. Vertical line test. I already told you, if you graph whatever it is, if it passes the graph twice or 3 times, it's not a function. It can only cross through the function once. So domains and ranges. All right, the domain is the numbers you can plug in, right? Any number you can plug in where the function doesn't choke. So this guy right here, this is a function. For any one number I plug in, I'm getting one number back, okay? But the thing is you cannot take the square root of a negative number in this class. After this class, you can do it all day long, okay? Because you get imaginary numbers or complex numbers. So if we're restricting our world to just real numbers, the domain here, we can't plug in a 5 because I would have 4 minus 5. I'd be taking the square root of -1. And that doesn't make sense in here, right? So I would say the domain, x has to be smaller than 4, right? 4 minus 4 is 0. So I'd say x has to be smaller than or equal to 4. That's the domain, okay? Now, what's the range? What's like well, here they just want us to do the domain. The range, it's easier if you graph it and eyeball it, right? If I put something in here bigger than 4, I'm getting the square root of the number, all right? So I could write it like that, or I could say interval notation, -infinity to 4. And I would put a square bracket here because I want to include the number 4. I can plug a number 4 in here. I could take the square root of 0, it's 0, okay? So that's why you use a square bracket. If you did not want to include the number 4, you'd put a round bracket, okay? So like this one here, as long as this number is bigger than 2, right? If I put like 1 there, I'm getting the square root of a negative. So I'm saying my domain, my x values have to be bigger than or equal to 2, right? So another way I could say that is square bracket 2 to infinity. That's my domain. Those are the numbers I can plug into this thing where it doesn't choke, right? So all this is saying domain is input, range is output. I showed you how to evaluate functions. We're going to evaluate some more here. So they give us several functions here. We have an f, a g, and an h. So here's f, g, and h. 3 different functions. So A, find f of 6. Well, here is f of x. They say take your input and subtract 2 from it and put that on the bottom, right? It's 12 over the input minus 2. This is 12 over 4, which would be 3, okay? G of minus 2. Here's G. It says take 1 minus whatever your input is squared. Right? So our input is minus 2 squared is 4. 1 minus 4 is a negative 3. H of minus 2. Where's H? H says take the square root of your input, subtract 1, right? Take your input, subtract 1, and square root it. That's what H says. Take your input, subtract 1, and square root it. So this is the square root of negative 3, which chokes. Can't take the square root of negative 3. Actually, you can. This is the square root of 3i, where I is the square root of minus 1. It's an imaginary number. Imaginary numbers are just as real numbers, but the term real number was already taken. Right? We use imaginary numbers and complex numbers all the time in engineering and physics because they represent things in the real world. So instead of a number line, you'll actually have a number plane. I don't know if you've seen that in your algebra class or not. So let's look at this one. They want f of 0 plus g of 1 minus h of 10. Well, what's f of 0? Let me give it another snapshot. Functions. Okay. F of 0. F said put a 12 over x minus 2. Here our x is 0. G of 1. G said take 1 and subtract your input squared. Now subtract h of 10. We want to put a parenthesis here, right? H of 10 says take the square root of your input minus 1. In this case, we don't need it. Sometimes you'll want this, right? Because of that minus, because that minus has to get distributed, okay? In this case, we don't need the parentheses. If this square root wasn't here, like if this didn't have that square root, you'd have to have those parentheses because this minus needs to go to everything, okay? That's why I'm bothering talking about it, otherwise it'll be wrong. So we got 12 over minus 2, that's a negative 6, minus 1 squared, 1. Square root of 10 minus 1 is the square root of 9. So negative 6 plus 1 would be a negative 4. The square root of 9 is 3, so we get negative 7. All right, evaluating functions. Just replace the input with whatever that number is. Finding domain. So again, domain is the numbers you can plug in where you get a number back. All right. So this one, the only issue here is you cannot plug in the number 2 because you can't divide by 0. So for this one, the domain is all x's except for 2. You could just say x doesn't equal 2. Or if you use interval notation, you would say anything from negative infinity to 2 unioned with anything from 2 to infinity. All right, these are two different intervals. Notice I used the round brackets. So I'm saying don't include the number 2. That's what this is all about. Everything up to 2, not including 2. Everything above 2, not including 2. This union is like addition symbol for intervals, for number intervals, okay? I like to just say all real numbers except for the number 2. The squiggly brackets is for sets, set notation. This is the set of all real numbers. This is like a minus sign for sets. And this is the set with the number 2 in it. So the set of all real numbers excluding the set with the number 2. So it's all real numbers except for number 2. So all three of these are the same thing. This thing, I can square any number I want and then subtract that from 1 and I get a number, right? So the domain for this thing here is any real number, any number you want. Plug in any number you want and it's fine. I could square it and subtract that from 1 and I get a number. This guy, square roots, I can't get a 0 in there. So if I have anything less than 1, it's going to choke. So my x's have to be greater than or equal to 1. Or in notation, interval notation, from 1 to infinity. Notice I would never write anything like this. This doesn't make sense, right? The numbers have to go from least to greatest, right? Infinity to 1, right? You'd write this, right? You might write this, all right? Negative infinity up to 1. That makes sense. It's not correct for this, all right? So that's not correct. This doesn't make sense. Infinity to 1 backwards. Of course, if you wrote that, I'd know what you mean. I'd know you meant this, right? Everything between 1 and infinity, including the number 1, is fine. All right. The difference quotient. You'll see that constantly the first 3 weeks in business calculus. The change in output over the change in input. This is the slope. See, if you have like, y'all know, if you have a line, mx plus b, that's your slope, right? That's your change in y over change in x. But what if you have something like this? Ooh. Well, the slope is different everywhere, right? So if you have, let's say this is f of x, what you want is another function called f prime of x that tells you the slope everywhere. We need to know the slope. For this line, we know slope. Well, here's a curvy ass line. What's the slope? Well, it depends on what x is. For each value of x, the slope is different. So the slope, instead of just being m, or number, is going to be a function in and of itself. And this, if you take the limit, as h goes to 0, meaning let h get smaller and smaller and smaller, this is going to give you the slope, also called f prime. All right, in algebra, you learn to use parentheses. Yes, y'all know how to use parentheses, right? 2 times x is 2 times h, right? The distributive property. That's what we did right after the quiz, right? I showed you the distributive property. All right, so if f of x is x squared, what would f of x plus h be? Well, instead of, this thing says take the input and square it. Well, my input is now x plus h, so that's what I square, okay? So I'm recycling x's here. This x is not the same as that x, okay? But f says whatever the input is square it. Here's my input, so I'm squaring it. I just square it, I get all that stuff, okay? All right, here's a function f of x. What's f of a? f of a is just a squared minus 2a plus 7. I just replaced the x with an a. What is f of a plus h? Well, it says take my input, square it, subtract twice times my input, and then add 7. That's f of a plus h. So f of a plus h minus f of a. So here's my f of a, right? And here's my f of a plus h. This would be my f of a plus h. Here, I'll make it green. And then I have minus f of a. Notice I'm putting some parentheses here, all right? Because we're subtracting all of f of a. Here is all of f of a. I need to subtract it. I need those parentheses so that that minus sign gets distributed, okay? So now we can, if we wanted to, we could simplify, right? What would this be if we simplified it? This guy is a squared plus 2ah plus h squared. Here I got a minus 2a, a minus 2h plus 7, minus a squared, minus minus 2a, and then a minus 7. So I can see that those cancel, those cancel, those cancel, and I'm just left with 2ah plus h squared minus 2h. Now they want to know part D, what is f of a plus h minus f of a all over h? Well, I already know what this is. It's that. I just found out and simplified it. I put that over h. Since everything has an h in it, right? Everything on the top has an h. I could factor the h out. This is h times 2a plus h minus 2. So since there's an h on the top and the bottom, this is just 2a plus h minus 2. So this shows up constantly in the first 3 weeks of calculus. Again, I said what you're going to do is take the limit. This is what's telling you the slope. This is the difference in y values. This is your difference in x values. And you're taking the limit as x gets smaller and smaller and smaller. So what this ends up telling you is the slope at the point A. Okay. When you look at this, it's like if h is, if you are considering let h go to 0, well, you can't divide by 0, right? But the thing is, we just showed that if you take this and finagle it, it's actually just this. And if h goes to 0, you just get 2a minus 2. And that would be the slope of the line. So calculus is all about dividing by 0. By getting a 0 on top, and you factor out the 0 over 0 and throw it away. All right? You just saw how it went here. Right? I got rid of this h on the bottom by finding an h on the top and making it go away. All right, let's see. Repeat for this. All right, let's look at this. So we're going to do calculus here. Find the limit as h goes to 0 of f of x plus h minus f of x all over h. Well, this is the limit as h goes to 0. So what is f of x plus h? I take x and I replace it with x plus h. Okay, that's this guy. Now minus f of x. Well, f of x is just x squared minus 4x plus 9. Then I have an h on the bottom. Now the limit as h goes to 0, you just plug in a 0 for h, right? That's where you're going. But if you do that, you're dividing by 0, and that's a problem. So in calculus, we just have to fix this. So if we multiply this thing out, x times x is x squared. We get the 2xh and the h squared. So that's that thing squared. So we got the minus 4x and the minus 4h. And then we have a plus 9. And then a minus x squared and a plus 4x and a minus 9 and all over h. So here the plus 9 and the minus 9 go away. The plus 4x and the minus 4x go away. The plus x squared and the minus x squared go away. So I'm left with 2xh plus h squared minus 4h. Since everything has h's in it, right, I could factor an h out at the top and the bottom. This is 2x plus h minus 4. Now, if h goes to 0, that goes away, and I'm left with 2x minus 4. This is your f prime of x. So if this is f of x, this function tells you the slope of this function for any x, right? Because if you graph this thing, it would look like this. Whoop, right? The slope is different everywhere. This tells you what the slope of this is, right? We like slopes. Slopes are rates of change, right? Business, right? How is your profit changing as time passes, right? Well, you need to know your rates of change. Also, right here at this point, the slope is 0. The slope is non-zero everywhere else, right? So if this tells you your slope everywhere, where the slope is 0, that's either a minimum or a maximum. You want to know how to minimize your profit and maximize your profit, right? So if you have a profit function, right, you'll be able to, what we call, take the derivative, which is this, and get its slope. Again, then you set the slope equal to 0 and solve for x, and that's your x. That's where you're going to minimize or maximize. That's going to be your entire calculus class right there. That's why they throw in this example, being able to do this. All I did was throw in this, which means replace h with 0 at the end. Blah, blah, blah. Cost function, price. Here's some business vocabulary. Cost function is your fixed cost plus variable cost, fixed cost, variable cost. Price demand function. X is the number of items that can be sold at P dollars per item. Okay. Price demand. Let's see. Revenue, number of items sold times price per item, right? X is the number of items, price per item. Multiply them together, you get your revenue. So your profit function is your revenue minus cost. All right. So this is okay, here we go. We're taking P here, substituting it in there. I don't know what M and N represent though. Positive constants. I get these. What is this? X is the number of items that can be sold. If you take the number of items, multiply it by, I don't know what the N and the N are. Maybe I'll do it. Price demand function. But anyhow, if you substitute that in, you can get your price demand function to be all this stuff. That's in terms of your revenue and your cost. That's your profit. Or your profit function. Revenue minus cost. They're taking the revenue and they're taking this version of it instead of just the XP minus that, minus the cost. You can substitute it in for the N's and the N's. I don't know what M and N is. Note the revenue and profit functions R and P depend on the price demand function, but the cost does not. Yeah, the cost doesn't care about how many items you can sell at a certain price, right? The cost is just the cost. You can make too many, or you can make not enough to sell. So we can make sense of this thing. Maybe we'll figure out what M and N are here in this example. All right, a manufacturer of a popular digital camera wholesales the camera to retail outlets throughout the U.S. Using statistical methods, the financial department of the company produced the price demand data in Table 4, where P is the wholesale price per camera at which X million cameras are sold. Notice that as the price goes down, the number sold goes up. Okay. So if the price is 87 bucks, you could sell 2 million of them. If the price is 68 bucks, you could sell 5 million of them, and so on. Using special analytical techniques, an analyst obtained the following price demand function to model the table. Table 4 data. Okay. Plot the data in the table, then sketch a graph of the price demand function in the same coordinates. This is boring. We need an animation for this. I don't want to do this. Plot the data in table. Where's the solution? There we go. So they're basically graphing this line, 94.8 minus 5x. Notice the slope is a -5, so that's downhill, right? The y-intercept is at 94.8. So it starts up here at 94.8 and then goes downhill at a rate of 5. Okay? What the part B is. What is the company's revenue function for this camera and what is its domain? They gave us P of X. R of X, the revenue is 90 million if they make 1 million cameras. Some more information here. Well, they give us P of X. Let's see. Where's our R of X? R of X is XP. Okay, so the number of items times the price per item. And here is our price per item. Yeah. So we would replace P with 94.8 minus 5x. So that's what P is, right? So we get 94.8x minus 5x squared. What is its domain? I could plug in any number I want into this and get a number out. So the domain would be all real numbers. Okay. It doesn't exactly make sense to have a negative number of items though, right? So really I would just say X has to be positive, it could be any positive real number. Okay. Now the range is different. I mean, the revenue, really what we want to know is the range, right? How much money can we get out, right? Sure, the domain is interesting. How many items can I make? I can make any number of items I want, right? I can make 10 billion cameras, but what I want to know is the range. So I guess we'll get to that in section 2.2. Complete the table 5, computing revenues to the nearest millions of dollars. Okay, so all they want us to do, since we have a revenue function, they want us to plug in a 3. So if we plug in a 3 here, calculate it and put the number there. They'll do that for all these numbers. So take a 6, multiply it by 94.8, subtract 5 times 6 squared, and so on. There's the table. They fill it in for us. All right, so there's the table filled in. Here was our function, r of x equals 94.8x minus 5x squared. Notice this thing's squared, that means curved, right? X squared looks like this, but when you take them, put a minus in front of it, it turns it upside down. That's why this thing looks the way it does. All right. So you can see here the revenue based upon millions of cameras. You kind of want to know what happens right here, right? That's your X value. You'd want to make what, 9 million cameras? Okay. Now, if you couldn't just look, I mean, it's hard to eyeball. If you're talking about millions of cameras and millions of dollars, you want to be like, it's about 9, right? What you'd want is the actual function. We know R of X right here. What we really want to do in your calculus class is find out where the slope of this function is 0, exactly where it's 0, because where it's exactly 0, the slope is 0, that's where your maximum is going to happen. So that thing we did with the limits, if you did that, if you did the limit of R of X plus H minus R of X all over H, as H went to 0, you would get out R prime. And that is the slope of this guy everywhere. And I could tell you by looking at it, it would be negative 94.8 minus 10x. That's the slope. So I'd set this equal to 0 and solve for x. And it would give me this number right here. That's how many cameras you'd want to make. So you could exactly maximize your revenue. And you'll have all the math to be able to do that now. All right, that's 2.1. Let's see, there was a day for the test that we're not having, and then a day for review, so that puts us 2 days ahead. So instead of doing another section today, we'll do the other section next time. And that'll still put us an extra day ahead of where we need to be. Because I want to be able to have like 2 or 3 lectures at the end of the semester just to do a review over everything for the final. All right. So we're going to do that. We'll call it an early day today. So let's do daily exam number 7. Find f of x plus h minus f of x all over h for f of x equals 2x squared minus 1. Okay. I could throw the limits in there. You may throw the limits in there. Oh, yeah, huh? Well, if you let h go to 0, you get 4x here. The trick is to find a derivative. You multiply by the exponent and then you subtract 1 from the exponent. So all that limit crap, you do all that, and then you're going to get 2 times 2 is 4, and then x to the first power. It's going to be a 4x. That's your slope. The slope of this guy everywhere is 4x. Let's see. Yeah, it's the way you're gonna go. Like your first 3 weeks of calculus, you have to do all these limits and all that, and then they finally tell you all you have to do is multiply by the exponent and subtract 1. Like, well, so you understand it, what it means, you know. You have to go through all that. Yeah, you got to know what's happening, man. Otherwise, you know, anybody could do it. All right, so let's do another one. Let's do. I'm gonna do anything too goofy here. Do 3x cubed plus 4x squared and minus 1. There you go. That's it for today. See you out there in Zoom land.